Well, I don't know why this didn't print properly, but this says speed of v, and the equation is 10 over 1 plus s. Okay, so tow speedboat travels along a circular path. Radius is 1. Toy has the speed of this, where s is given in meters along the circle, just like usual. S equals 0 right here. And the time right there, this is s equals 0, and the time here is 1 second. Okay, so they want to know what is the time when the boat gets to B. So you are given the speed, and you would like to have an equation for position versus time, because you know what the position is. He gets over to B, and so you know what the position is. You want to have time. So if I have velocity and I'm looking for position, I need to integrate. So what I'll do is I'll say, okay, ds dt, s is the distance along the curve, is equal to speed. All right, and speed is equal to 10 divided by 1 plus s. Now, is the acceleration constant? It doesn't look like it is, and so I cannot use the handy formulas for that. I'm going to actually have to integrate. So how do you solve this? You separate the variables. Can you separate the variables, or do you need the chain rule? No, you can separate the variables. So the variables go like this: 1 plus s ds. Now, admittedly, there's only a few homework problems where you put the s over on the left-hand side, but it's the same thing. You're separating the variables, right? That's all you're doing. 10 times dt. Okay, so integrate both sides. Over here, that is not too hard to integrate. This is going to be s plus s squared over 2 plus an arbitrary constant equals 10 times t. Okay. I think in the solution, I did put the c over here. Doesn't really matter. But anyway, okay. How do you find the c? The same way you always find c. You have a time and you have an s. You have one right here. When time equals 1, s equals 0. So that would be 0 on the left-hand side plus 0 equals 1 times 10 is 10 plus c. So c is equal to a minus 10. Okay. Having that, I can then put in s plus 1/2 s squared is equal to 10t minus 10. All right, now, you want to know the time when it gets to B. Well, what's the s when it gets to B? Well, what's the radius of that, or the circumference of that half a circle? Well, here's what I know. I know 2 pi all the way around times the radius is equal to the circumference of a circle. So half of that is half a circle. And that's equal to the s. So s is equal to pi. So this would be pi plus 1/2 pi squared equals 10 times t minus 10. Can you solve for t? Yep. And I believe t comes out to be 1.8. Okay, so that's the time. What is the acceleration? Okay, I'm given the speed, and let's see, v equals 10 over 1 plus s. Okay, now, the acceleration, do you want to use x and y? No, that's kind of dumb, because it's not moving in the x and y, it's on a circle. Should you use tangent normal? Yeah, it sounds reasonable, because you're talking about speeds and changing speeds, things like that. Okay, acceleration for tangent normal is v dot in the tangent direction plus b squared over rho in the nn. Okay, now can we find the v at point B? Yeah, magnitude of at b. Okay, so do you know the v at b? Yeah, so we can go in here. V at b equals 10 over 1 plus, and what's the s at b? It's equal to pi. All right, so that gets you the v. What's the rho? The rho is equal to 1. So can you get v dot? Okay, well, can you take the derivative dv dt? And v is equal to 10 over 1 plus s. Okay, can you take a derivative of this? The derivative of... Okay, let me back it up. Okay, you have v, you want dv dt. Can you take dv dt of 10 of 1 plus s? No, you can't. Why? Because it's got s in it. Okay, so you multiply by s over s, and then you swap the bottoms, dv ds, ds dt. Now, s is position, so the derivative of position, ds dt, is v. So this is v, this one is v, times dv ds. Can you take dv ds? So you take v. Can you take dv ds? Yeah, I can take the derivative of this with respect to s. So that would be... Okay, so let's take the derivative of this guy. So that would be, I'm going to write it as 10 times 1 plus s to the negative 1 power. Okay, so I'm going to take a derivative of this. That would be 10 times, bring the power down, times the stuff being raised to a power minus 1, times the derivative of what's on the inside, times the chain rule, the chain rule is down here on this guy. Okay, so what do I have? I have a minus 10 divided by 1 plus s quantity squared. That's the derivative there. Okay. What is v? You got it. It's right here. So dv ds is v, 10 over 1 plus s times a minus 10 over 1 plus s squared. That'll give me a 1 plus s to the cube right there. Okay, so what is v, what is v dot? This is v dot. V dot. So what's v dot? V dot is equal to 100 over 1 plus s is pi cubed. Put that negative right there. Okay. So my calculator says that this is negative 1.41. All right. So what's the acceleration? Acceleration is equal to a negative 1.41 in the nt direction, plus v squared. V squared is, v is 10. See, did I get that? Hang on. I don't know, I got it somewhere. Yeah, this guy, 10 over 1 plus pi, is 2.41. Okay, sorry about that interruption. All right, so VB is 2.41. So I'm plugging into this formula right here. And V is 2.41. So we have 2.41 squared over radius of curvature is 1. And that'll be in the NN direction. All right, so this is equal to a minus 1.41 NT. That ends up being, according to my calculator, 5.83 in N. Now you want the magnitude. So the magnitude is the square root of 1.41 squared plus 5.83 squared. And my calculator says that is 6. And that's the way you do that one.